David with Liguori Jag Racing, and let's talk progressive nitrous control. You have two progressive nitrous controls in the FuelTech software. Progressive nitrous control number 1, if you don't see it in other functions, you need to go down to map options and select your progressive nitrous controls. You have a control type by RPM, speed, by time, manifold air pressure, gear and engine RPM, or gear elapsed time. So let's look at RPM first. You can see that we can have a progressive RPM. So for example, if we put 0 here and ramp it to 9,500, we have a ramp that is going to follow that through every RPM range that we go through. By speed, we have a mile per hour, so we can adjust a ramp based off of mile per hour. And if you're not sure how I'm doing the ramp here, go check out my horizontal and vertical interpolation video. By time, which is most common, we're going to save that for last. Manifold air pressure, we can do a ramp based off of adding boost or something like that, maybe on the 2-step. So we can do that by manifold air pressure. Gear and engine RPM. So this, we have a RPM based nitrous duty cycle at first gear. So we can put, say, first gear all at 20%, second gear at 30%, fourth gear or third gear at 60%, fourth at 100, and the rest of them at 100 if we wanted to. Gear elapsed time. So this is the time within that you're within that gear. So when you do a gear change from first to second, you're in that gear for a certain amount of time. Same thing for first after a launch. So if you don't want the ramp to start until after you launch, you can put say you're in the gear for less than 2 seconds. You can put, say, 30% here, but you want it to start at a half a second. And then if you're not in first gear for more than 2 seconds, then you don't really have to worry about the 3-second mark. Or you can change the axis, which we'll get into that as well. And then you can start at 30% here and ramp it to, say, 60%. You can pretty much customize it however you want based off of your second gear and time. Do the following for third, fourth, fifth, sixth, so forth. So we'll go back to time because that's most common. And when we do time, your file is not going to be set up like this to begin with. This is how I made this axis. You can right click on the top axis and you can edit this. So what I did was I come in here, my first value is 0 seconds, last value 7 seconds, and I want to do an increment of a 1/4 second. It'll require 29 spots, 29 spaces, and we can see that it adjusted this a little bit when I click that. And you always want to have your highest number that you're not going to achieve. So if this is a 8 second and under bike, so like a 7 second bike, you want at least 8 seconds in this column here. Usually I run like a second and a half over it or something in case something happens where I have to get out of it, or whatever might happen. If I'm going to have a bad run, I can have the nitrous stay on if I want it to. So there's a 9-second range, so you can see that the table goes from 7 seconds to 9 seconds at the end. And then you can adjust your values for the solenoid ramp here. So if you wanted to leave on motor, put that at 0, and you wanted to start at 1 second and ramp to 4 seconds, highlight those, click H, and it snaps the table down. If you wanted to start at 15%, and then you wanted to gradually go up, you can just click these and adjust with the up arrow, or the plus button, sorry. You can really do whatever you want as far as ramp based with time. And you can also, I've seen guys drop solenoid time, something like this. So you can really customize it however you want. So that's by time, and we can enable the progressive nitrous by always enabled, external switch, a dashboard switch, or synchronized with Pro Nitrous. So I personally always, since it's a nitrous bike and I run nitrous all the time, I have it always enabled. And what this means is your bike will not, I repeat, will not spray nitrous if there is no validated launch. So for example, if you get crazy and you're 90% throttle in the burnout, maybe when you're pulling out of the burnout or something, you wick it, it's not going to spray the nitrous because you didn't go up on the two-step first. If you go up on the two-step before you do your burnout, then it can trigger a validated launch and then ultimately spray your nitrous. But if you don't do any of that, if you don't go up on the two-step, then you don't have to worry about that at all. So just keep it always enabled. If you don't use the two-step before you actually want to launch the bike or vehicle, keep it always enabled. That way you never forget it. You never have to remember to turn it on or whatever. I've seen a lot of guys go up to the line, not turn the nitrous on, and make a bad pass. You can do an external switch, and that will be a progressive nitrous control number 1, progressive nitrous number 1 arm switch, if it was number 1. You can do a dashboard switch. So we can come to the dashboard, we can select wherever we want, we can put a progressive nitrous number 1 arm switch on the dashboard, and we can make it a different size. So there we have to click that every time we want to arm the nitrous. And you can synchronize it with Pro Nitrous. So if your Pro Nitrous is on, then you can turn your progressive nitrous on with one switch. We'll do Pro Nitrous in another video because it's not anything to do with progressive. Next option, pre-launch actuation. I see a lot of guys mess this up. They want to click two-step here, and what this means is if you have that active, it can spray the nitrous on the two-step. It's pre-launch activation, so it's everything before you want to launch the bike. So if you want to use the nitrous on your two-step to build boost, this is where you would do that. if you want to use it on a 3-step to build boost, if you want to use it on a burnout, things like that, mostly in the turbo application. But it should not be check marked to spray nitrous unless you want it to, unless you absolutely want it to. Input activation mode, this is just an external switch. We can activate it by a ground signal or a 12 volts. You can disable when engine temperature is under a certain temperature. Nitrous PWM for pre-launch. So this is pre-launch activation. If you wanted to use the pre-launch for building boost on the 2-step or what have you, you can put in whatever percentage you want here. You can put in whatever fuel you want, 16%. And then it'll calculate the pounds per hour as well. Timing retard for pre-launch. If we want, say we want negative 12 degrees. Minimum RPM for activation. This has nothing to do with specific to pre-launch. This is just a minimum RPM activation for the whole nitrous control. So it won't spray under 2,500 RPMs, and the maximum RPM is 11,650. I usually try to put this roughly 150 to 200 RPMs below the rev limiter. That way the nitrous shuts off, hopefully before it hits the rev limiter. Total time to return PWM control. So if you have 1 second here, and you have base DC for PWM control return to start at 30%. This has 3 safeties in it. You have throttle position over here, and you have your minimum RPM, you have your maximum RPM. So if you were to lift off the throttle past 90% and then get back in it, you're going to start at 30%, and it's going to ramp to wherever the duty cycle table is in that progressive range by 1 second. So if you're down track, say you're at 5 seconds into the run, and you rip the throttle, get back into it, for 1 second, it's going to start at 30%, and then it's going to ramp to 100% in 1 second. If you have this at 20, it's going to start at 20. If you have this at 0, it's just going to go exactly back to wherever the return map is. So if you lift at 2 seconds, it's going to go right back to this number. If you lift at 4 seconds, it's going to go right back to this number. If you have a half second here, and you lift here, and it's going to be a half second, so you rip the throttle, get back into it. By the time you're here, it's back on. It's going to start at 30%, and then for a half a second, it's going to ramp to this. Because you started here, it's going to ramp to this because that's a half a second. NOS fuel compensations. You can have an on delay time, an off delay time, and an off ramp. So your off delay will be a 1/10 of a second, and then it will ramp off another 1/10 of a second. Same thing for ignition timing. On delay, and off ramp. Progressive output by TPS. If you were to lift, you can have this. I don't recommend 10%, but if you have, say, 50% and 90% here for 100% of nitrous. So anytime that you're above 90% nitrous or 90% TPS, you're going to have 100% of nitrous. If you're anywhere between 90% and 50%, then it will be a percentage based off of where you're at with your throttle. So this is good for like clutch cars or clutch bikes with true hand clutches. And then you can have, if you disable that, you just have turn on with over 90%. PWM frequency, typically anywhere from say 15 to 30 hertz is normal. This is the amount of time that it progresses or pulses in 1 second. So 15 equals 15 times per second. Output signal, I always recommend any type of nitrous to be on a ground activation. I do not recommend anything on 12 volts with a yellow output. Do it off of ground. Alright, so we went over progressive nitrous control settings. We went over time-based. Let's go over progressive fuel table by nitrous duty cycle. So at the top here, we have percentage, and this means percentage of nitrous duty cycle. So it is these numbers here in your time-based. At 80%, we have 56 pounds per hour of fuel added, and we have a ramp coming from 10%. Normally when you open this file up for the first time, it's going to be on DC percentage. So you're going to have percentage here instead of pounds per hour. And to change that, you click F6. F6 changes that from a pounds per hour number to a percentage number. Me personally, I always like to do pounds per hour, so I'll switch it back to pounds per hour. And a good starting point. Now this is a starting point. I'm not telling you how to tune your bike. This is a specific starting point. If you're running a race gas or a gasoline, you can come to engine setup and you can look at the brake specific fuel efficiency numbers. Race gas 0.45 to 0.55. So roughly, whatever nitrous shot you have, if you have 100 shot, then you roughly need to start between 0.45 and 0.55. And that is, in the middle is 0.5. So you take the 100 shot and you divide it by 0.5, and that's just half. So we can start at 50 pounds per hour of fuel, and then we can ramp it from, say, 0 if you wanted to. So this is a good starting point. Now, the reason why I have it set to 80% here is because most nitrous solenoids can't activate below a certain percentage and above a certain percentage. They just can't physically open and close that quick. Has nothing to do with your controller, because your controller can command it, but the solenoid has to mechanically open and close based off of what the percentage is. So if you have a real big solenoid, like a 1.25 orifice solenoid, or sorry, 0.125 orifice solenoid, it might not even open at 15%. You might have to ramp this thing at 18% to start with. And it might be wide open at 75%. And a good way to know what your solenoid is doing is to look at bottle pressure. So this is a test that I did in the garage at a 15 hertz test. You can see that I commanded the nitrous to start coming on at 0 seconds. But the bottle shows that the bottle pressure shows that it didn't drop until 11%. So this solenoid will not open below 11%. So when you make your duty cycle ramp, you have to make sure that you start at least 11% or your nitrous isn't going to spray. And you can see at the end here, when the nitrous levels off, it levels off pretty much 100% right here. You're at 90%. This isn't really doing much anyways either. So if you look at 80%, this isn't, you're not pulsing the solenoid that much. So just have all your fuel in by 80% at least. And that way you can keep your engine safe. But when you're doing a ramp down the track, you can see where your solenoid opens and when it closes. So we'll go back to the fuel table. That's why I have 80% here. And, at 10%, it's really not doing anything, but it's still going to add that little bit of fuel before the nitrous kicks on. And this is just a good starting point. Like I said, if you run E85, then I would use these numbers here. If you use E100, use these numbers. If you use methanol, you have to add literally what your shot is, or more. So these numbers here are in engine setup, as long as you have a newer version of the software. If you don't, then you can just look at this video, or you can look up just brake specific numbers, brake specific fuel calculation. So that's the fuel, and that's how much is going to be added off of a percent. Next, we have fuel enrichment by TPS. I normally never use this, but you can add or remove fuel based off of throttle position and engine RPM. Progressive timing table by nitrous duty cycle. This is the same thing as progressive fuel table, but with timing. So it goes off of nitrous duty cycle. So if you wanted to pull 12 degrees of timing, then you should start at, say, 80%, like with the nitrous solenoid opening and closing. Then you should start your full timing here that you want to pull, and then you can start pulling timing based off of where you put your ramp. So, for example, if we ran on motor for 1 second and then ramped to 100% in 5 seconds, you're going to start pulling timing at right over 0%, because this is a ramp also. So at 10%, you're going to pull 4 degrees. So right in this range, right before this. And then at 100%, you're going to pull -12. Now, if we want to change our ramp, and we want to leave on motor for 2.5 seconds and then ramp it, we don't have to change our timing numbers. We don't have to change our fuel numbers, because it will still add fuel and remove timing based off of this nitrous duty cycle. Auxiliary timing retard compensation. You can retard timing based off of engine RPM additionally on top of this if you would like. I'll briefly go over progressive nitrous control number 2. You have all the same options, except you can synchronize with progressive nitrous number 1 control. So a lot of guys use this for a second nitrous kit, for like a catch-up button, a scramble button on nitrous. So we put it at engine RPM, external switch. We have our external switch labeled progressive nitrous number 2 arm switch. And then we can RPM base it 100%, just turn the nitrous solenoid on. We can put our fuel tables in. Now, if you have it at 100%, nothing here matters. But if we wanted to ramp it, we have the ability to ramp it also. Same thing with this. Nothing matters here if we're only at 100%. But if we want to ramp it, we can ramp it. You have the other same settings. All the other settings are the same. I would suggest having the maximum RPM for activation the same on both. So that's progressive nitrous control number 2. Now, when using time-based nitrous duty cycle control with progressive nitrous control number 1, you also need to adjust your closed loop. And I suggest using O2 closed loop, using an auxiliary target table by time-based. And when you have a time-based, you can see that time-based will pop up over here, auxiliary by time after 2-step. So when you release the 2-step or the box counts down and you actually launch the bike or vehicle, it starts at 0 seconds. And this is your air-fuel ratio based off of time. So, for example, what I normally do is if I have my ramp starting at 18% and then at 4 seconds I have 100% of it in. So I'll look at 4 seconds. I'll scroll back up. Before 4 seconds, I want all of the O2 closed loop to basically be in or be all the way at that point. Because remember, the nitrous solenoid only works up to about 80% and then it's wide open. And then if I'm starting my ramp, I want to start the ramp at a lower air-fuel ratio also than I usually run on motor. So this is a motor air-fuel ratio. And I can ramp the fuel, I can ramp the closed loop into it, and I can ramp the fuel into it based off of the progressive nitrous control, progressive fuel table. So it's ramping fuel in, and it is lowering my air-fuel ratio at the same time. Now, these numbers don't mean that this is what your bike wants. This is a Q16 bike, needs a lot of fuel. So don't use these numbers specifically. You have to use your own numbers for your own bike. You also have an auxiliary by time-based control limit. So based off of time. So you can do this at all 10%. You can do it at all 20%. Again, when you're tuning this, you want to get in the window of within 5%. If you're within 10%, you're probably pretty good. I try to narrow mine down within almost 0%. So it's not correcting that much. If it's correcting a lot, then it's just fighting you the whole way down the track. So get your closed loop as tight as you possibly can to your target. But if you don't do this, if you don't enable the time-based and you just use your target table here, then all of the fuel that you add is going to try to be pulled back out. And if you have a big control limit here, then it's going to pull it back out, say 40% if you have 40% there. So you need to adjust your auxiliary by time after 2-step, and you have to do it based off of your nitrous duty cycle table.